Hey, 20-1s. Here is another lesson in trigonometry. This one's going to be about finding exact values of our trig ratios. So again, the word exact value means we're not going to write anything as a decimal. We're going to start writing answers like that. Okay, now this is going to be a little complicated, and it is of extreme importance for 30-1. Out of anything you're going to do in trig in grade 11, this lesson is really important for next year. Okay, so maybe watch it a couple times. I'll try not to keep it too long. Okay, what we want to do here is we want to find exact values. We really don't like rounding in math. And here's what I mean. If I go and grab my calculator and punch in, let's say, sine of 60 degrees, we're going to get some long decimal. And we really don't like that, okay? We're going to have to round it. That's a big deal. We don't like doing that. So that's our job today, is to get rid of those decimals. Here's how we're going to do it. Before we start talking about these exact values, we're going to go and we're going to draw two special things called the unit triangle and the unit square. That word unit simply means we have a side length of 1. That's what that means. Okay, so we could have the unit circle, which we'll see in grade 12. You have the unit hexagon. All it means is it's a shape with a side length of 1. Okay, what I'm going to do first is I'm going to draw a square. And I'll try and draw it as straight as I can. Not too bad given how much coffee I've got in me. Okay, and it's a square, and I said it's the unit square, so all the side lengths are 1. Okay, but wait a minute, we're in trig, so we want triangles. So I'm going to make a triangle, and all I'm going to do to make a triangle is I'm going to draw that diagonal there. And so now I've got two triangles, but they're congruent, they're the same. So the angles in this triangle, well, that's 90. We bisected the 90, so these are both 45. Okay, easy peasy. Well, now, how long is this hypotenuse here? Well, if I wanted to find that hypotenuse, I'm going to say a squared plus b squared equals c squared, right? Our favorite formula of all time. And I'm just going to isolate for the hypotenuse. And so what we see is our hypotenuse is root 2. Okay, and you're saying to yourself, okay, got it, no big deal. But why? Why is this helping me? Why do I care? Well, because of this. Watch what we've got. Grab your calculator, and I want you to put in your calculator right now sine 45 degrees. So if I put sine 45 in my calculator, here's what I'm going to get. I'm in degree mode. I go sine 45, and I get 0.70, yada, yada, yada. Like it's just going forever. It doesn't stop. It's irrational. So I don't like this. I don't like the fact that we're saying this. This is approximately this, and it keeps going. Well, now let's look at the triangle we just drew. Sine 45 degrees. Well, I know that's opposite over hypotenuse from grade 10. So going from here, this would be opposite over hypotenuse would be 1 over root 2. If I wanted to rationalize that, I multiply top and bottom by root 2. You don't always have to do that, but sometimes you do. Go ahead, let's put this in our calculator. So I go to my calculator and I'm going to put that in it. So I'm going to say the square root of 2 divided by 2. And what do you see? The exact same set of decimals. So what does that tell us? We just figured out the exact value of sine 45 is root 2 over 2. That is what the point of this lesson is, finding the exact values. Okay, well, what's cosine 45? Well, cosine 45, again, going from 45, is adjacent over hypotenuse. Well, hey, look at that. We actually get the exact same value as sine 45. There you go. There's the exact value of cosine 45. Okay, what about our last one? Tangent 45. Okay, tan 45. Well, tangent 45 is opposite over adjacent, which is 1 over 1, which guess what is just 1. Look at that. What we just found was the exact value of 3 trig ratios. Okay, and we're going to need to know these. So I don't want you to memorize these. I want you to know where these came from. It came from the unit square. And then we made what is known as this black triangle. This is a special triangle, is what most people call it. It's a special triangle because it gives us these exact values. Okay, look at that. We know 3 exact values. Well, there's the unit square. Well, let's draw the unit triangle. How does the unit triangle work? Pretty much the same. So the unit triangle has a side length of 1. So then it's an equilateral. So if all sides are the same, then I know all angles are the same. But I don't know how to work with a triangle that's not a right triangle yet. So what I'm going to do is I'm going to drop down a perpendicular like that. I'm going to look at this triangle right on this side. So the angles in here then would be 60. The one at the top, we bisected it, it would be 30. Since we bisected it, the side length at the bottom is a half. There it is. Okay, so what I'm going to do is I just want to focus in on this triangle. Well, we need this missing side length right on the side here. Okay, so again, we would find that using good old Pythagorean, right? Our favorite cult leader of all time. I'm just going to tell you, save you some time, using Pythagorean, that's going to be root 3 over 2. Okay, so let's find some exact values. Let's do 30 degrees first. So sine 30 degrees. Sine is opposite over hypotenuse. Well, that's 1/2 divided by 1. That's just a half. Hey, that's easy. What's cosine 30 degrees? Cosine 30 degrees is adjacent over hypotenuse. That's root 3 over 2. Awesome. Okay, and then what is tangent 30 degrees? Well, tangent 30 degrees is opposite over adjacent. So it's a half divided by root 3 over 2, which is a half times 2 over root 3. And I apologize, I'm going to go sideways here. The 2's divide out. That's 1 over root 3. And if I wanted to rationalize that, that's root 3 over 3. We just found 3 more exact values. Cool. So now we've done 45 degrees, 30 degrees, but I see that 60 staring at me right there. So let's do that 60. So let's do the same thing. So sine 60 degrees is, just going to erase some of my lines here, opposite over hypotenuse. So in this case, this is the opposite. And the hypotenuse happens to be 1. So that's that. Cosine 30 degrees. Well, cosine is, 60 degrees. Maybe I don't have enough coffee yet, hey? Cosine 60 is adjacent over hypotenuse. That's a half. And then what's tangent 60 degrees? Well, tangent 60 is opposite over adjacent. So it's root 3 over 2 divided by a half, multiplied by the reciprocal, and you're going to get just root 3. Okay. This, my friends, is so important. How we derived these exact values. Okay, this is so important for 30-1. So what we just did was we found the dimensions, exact values of our special triangles. So I would like you not to have this memorized. I mean, I've got it memorized because I've been doing it for pretty much ever. But what I would prefer you to do is to know where these values came from. Okay, because next year when you get to grade 11, or sorry, to grade 12, and you're going to say, okay, I don't remember these values, and I don't expect you to, but I want you to remember where they came from. They came from us drawing the special triangles, and the special triangles came from the unit square and the unit triangle. Okay, you're going to use this a ton in grade 12. You're going to use it right now as well, but in grade 12, this is a big deal. Okay, let's use these. Here we go. For the following, draw the angle of rotation, state the reference angle, and the exact value. I get that in there, typo. Okay, cosine 120, got it, check. Draw this thing in, it says. So cosine 120, so I'm going to draw my terminal arm somewhere over here, right? Remember, always draw to the x-axis. Okay, what's our reference angle? Well, our reference angle is the acute angle measured to the x-axis. Well, if this is 120, that's theta. Our reference angle is right there, theta sub r. So our reference angle, well, if we want to think of this, we're going to go 180, which is right here, minus theta, which is 120. So our reference angle is 60. Okay, so there's your reference angle. So why do I care? Because if I know the reference angle is 60, that's from one of our special triangles, isn't it? So look at what we know. We know that sine 60, and let's just do cosine 60. We can go back up to our little sheet that we made here and said, look it, I know sine 60 is root 3 over 2, and I know cosine 60 is 1 over 2. So sine 60 is root 3 over 2, and cosine 60 is 1 over 2. But we didn't start the question with 60. We started the question with 120. So guess what? Sine 120 and cosine 120 are going to have the exact same ratios, except we have to watch the sign based on the quadrant we're in. Why did I write root 3 over 2? 1 over 2. So what quadrant are we in? Well, this is where the cast law comes in from the last lesson. In quadrant 2, sine is positive. So these will remain positive, but cosine is negative. So cosine is negative in quadrant 2. And why did I draw a theta there? Maybe I need some more coffee, hey? 120. There it is, friends. And here's how I'm going to check my work. I'm going to go to my calculator, and I'm going to punch in these values. Watch. Clear my screen. Sine 120. Enter. And there it is. It's positive 0.866. Guess what that is? That's the square root of 3 divided by 2. That's the exact value. I want to check the other one. Cosine 120. Remember, we said this should be a negative. So watch what happens. Negative 0.5. That's exactly what we said it was. So we can check our work, and I think you really should these first few times. Okay, let's try another one. Sine 330. Okay, so draw our standard position. Where are we? Terminal arm then would be down here in quadrant 3. Boom. I'm going to draw the cast law now that we know we need it. I'm going to draw it on every single question. Cast law. Okay, so I'm going to draw in my angle. Theta goes from here to here. That's theta. Inside our triangle is our reference angle. That's theta sub r. Beautiful. Okay, so first off, let's find that reference angle. Well, the reference angle would be 360 minus 330. So our reference angle is 30 degrees. Okay, how does that help us? Well, then what I know is I know sine 30 is 1/2, And I mean, it's only asking for sine 330. So I'm just going to stick to sine on this one. So what do I know then? Well, what's sine 330 then? Well, sine 330 is going to have the same value, but then I say to myself, is it positive or negative? Well, in quadrant 4, cosine is positive. So that means sine is negative. There is your exact value of sine 330. Okay, like I said, a little tricky. Let's try a couple more. We want the exact value of sine 225. So Cartesian, Casla, draw our terminal arm, 225s down here in quadrant 3. Okay, so right off the bat, I know my answer is going to be negative because tangent is the only positive ratio here. Okay, what's our reference angle? Well, let's draw in our angles always. That's theta. That's theta reference right there. So what is theta reference? Well, I'm going to say we went 225, but that's 180. So I'm going to say 225 minus 180 is 45. There's my reference angle. Okay, so what is sine 225 then? Well, first I'm going to say what is sine 45? Sine 45, we determined above, was root 2 over 2. So what is sine 225? Well, sine 225 is going to be the same, but in quadrant 3, sine is negative. There's your answer. Okay, so again, I can check my work by putting sine 225 in my calculator. I'll even show you one more time because I want you doing this. Sine 225 negative 0.707. Guess what? The answer we said was negative root 2 divided by 2. And I forgot the negative, but you can see we get the same value. So again, all we're doing is finding these exact values. Okay, let's try the last one. Tangent 60. Okie dokie. So, bam, bam, Cass law, 60 degrees in quadrant 1. Okay, quadrant 1's the easiest because we don't need to find a reference angle. 60 is our reference angle. So in quadrant 1, life is a lot easier. There's theta, which is the same as our reference angle in quadrant 1. Okay, so guess what? All we've got to do then is just say tan 60, and we just go back up to our little chart. And again, don't forget, this is why we want to know this thing, because now I just go to my chart and say, bam, there it is. It's root 3. Done. There it is. So finding the exact values. Okay, so like I said, this is a trickier lesson. I would watch this again and I would practice drawing my unit square and my unit triangle, and I would definitely write out that chart. Okay, see you next time, friends.